Kia ora Year 9. This is a really challenging task on linear equations to give some of you something a little bit harder to think about. Now, it's by a great UK mathematician called Steward, and I've used some of his problems in class before, but he's said that it's okay if I video some of his tasks, which is fantastic. So I'm going to show you the first one here. If you're watching this and you're from another class, you could ask your teacher to chuck the questions up onto your Google Classroom. So it's got a couple of bits to it, and the first part is the weird bit. So it starts off with this Venn diagram, which looks kind of scary, but it's quite fun. And it's got 3 circles on it. And the circles are all features of linear equations. And the first 2 I'm going to highlight here are ones that we're really confident with. The first one's the gradient, which we call m, and the second one is the y-axis, the y-intercept, which we call c. So remember, so far, we've done lots of work at figuring out y equals mx plus c. So if I give you a line like y equals 2x plus 1, you can tell me straight away that the gradient of that line is 2 and the y-intercept is 1. So that sorts out these 2 things here. And what we're looking for is we're going to have a bunch of different equations and we have to sort them into groups. Which ones have got both a gradient greater than 2 and a y-intercept greater than or equal to 8? And they're going to go in here, right? So hopefully you've all got the idea of Venn diagrams already, but they're pretty intuitive, and they're a really nice way to look at how we can combine different features, right? So let me just clean that up. Now, the interesting thing in this problem that makes it a bit more challenging is this third circle here, which is all about finding the x-axis intercept, and we have to figure out whether it's less than or equal to -3. Now I'm going to come back to what this means, but you're going to do that with these equations, right? So you're given 10 equations and you basically have to sort them out. It's like when you were a little kid and you had those things, those shape machines where you had to slot things in the right slot. That's what this is all about. But here you have to take each of these equations, you have to find out m, c, and the x-intercept. And then you go back to your Venn diagram and you work out, hey, which red dot might that equation be? So if you've figured out that number 5 is this one, you're going to put a little number 5 next to it. So before you ask me, yes, you are allowed to write on the sheets that I'm giving you for this one, or you can just do this from the video as well. Either will be fine. If you're going to do it from the video, you'll have to copy that diagram down. So the instructions I've given you on the sheet go like this. So you pause the video and just have a read of those. The new thing here is the x-intercept. So let's take a look at what that's all about. Well, let's look at this line here, y equals 2x plus 1. If we draw that badly, as usual, it looks like this. My y-intercept goes on at 1, and then I can draw another point, and I can get that point using the gradient of 2. So I go out 1 and up 2. So we know that the point 1, 3 will be on my line. Now I could have done that not using my graph, but by substituting a value in here. So when x equals 1, we get y is equal to 2 times 1 plus 1, which is 3. And you should be good at both of those methods, right? And then we draw our line using a ruler, and it looks like that. So the x-intercept is this point here. Where does it cross the x-axis? And hopefully without too much thinking, you'll see that this is happening when my y value is equal to 0. So what am I doing? Well, I'm saying what x value is going to make the y value 0. So to find the x-intercept, we substitute y equals 0. And we always do that. It doesn't matter what form of the line we're in or how complicated my equation is. So we get 0 is equal to 2x plus 1. We can solve that as follows. So -1 is equal to 2x and x is equal to -1/2. So instead of having 2 key features of my graph now, I've got 3. I've got the gradient, which is 2, and I've got the y-intercept, which is 1, and now I've got this new weird thing called the x-intercept. So for this task, you're going to have all of these equations, and you're going to have to figure out what's the gradient, what's the y-intercept, and what's the x-intercept. And then you're going to have to figure out which dot is which on your Venn diagram. So it would be good to have a systematic way of recording all of that stuff. So I want you to have a think now about what would be a nice method. You're going to have a whole lot of working in your book, and then you need a good, clean way to record. So this is what I came up with. Where's it gone? Here. I think using a table would be a really useful way to summarize what we find out. Right, so here we're going to have the equation. And here we're going to have the gradient. Here we're going to have the y-intercept. And here we're going to have the x-intercept. And once you've done that, you can very easily figure out which red dot is which in the Venn diagram. So I'm going to start you off with a couple because these equations have been written in different ways. So here are the equations. Let's take a look at the ones that are in our usual format. We'll spot those pretty easily. So this one here, y equals 2x plus 12, equation number 6, that looks fine. Right? This one here, y equals 4x plus 10, is also in the usual format. But all the others have been written not in y equals mx plus c form. So we're going to have to do some rearranging to get them back like that. So let's take a look at number 1 first to give you the idea. Well, this is just about in the usual form. Instead of having y equals blah blah, I've got 3y equals blah blah. So I'm going to divide both sides through by that to have y equals 7/3 of x minus 6/3. Now 6/3 is just 2. So when I look at this equation now, I can very easily figure out the gradient, 7/3, and I can figure out the y-intercept of -2. How can I figure out the x-intercept? Well, remember the x-intercept is where y equals 0. So there are two places I can do that. I can either do it in my cleaned up version and go 0 is equal to 7/3 x minus 2, which gives me 2 is equal to 7/3 of x. 6 equals 7x. X equals 6 over 7. So you can see there's a bit of work in this task, right? So that's my x-intercept. Or the other way we can do it is we can go right at the start, substitute y equals 0 into here. So we started with, what did we start with? 3y equals 7x minus 6. Now I can start off right away by saying y is 0. So this is 0. So 0 equals 7x minus 6. Now that was a lot less work, right? So we get 6 equals 7x. 6/7 is equal to x. So that's how we get the x-intercept. Okay, so that's all of the starting point clue that I'm going to give you because I don't want to take the fun out of it. But work together on this one and do make sure that you record your working systematically. And don't forget that the task is to figure out which equation is which dot in here. So the end of your investigation should end up with little numbers on the dots like 9, 1, 2, and 4. Thanks for watching. Have fun, and I'm sure you'll let me know if there are any problems.